Hey, let's start talking about ellipses now. Welcome to the teaching video. Thanks for joining me. We're going to talk about some key characteristics of ellipses. There's some terminology that you're going to need to know, things to look for. We're going to learn, once we learn some of those features, we're going to learn how to write an equation of an ellipse. Like let's say they give us a vertex and a co-vertex. We're going to learn the relationship between the foci and the vertex and co-vertex, and then we're going to be able to find the foci and the focal length, and then we're going to be able to write equations if we're given the foci and a vertex. So let's get started. There's a lot on this slide, so I'm going to talk kind of slow, and so just try and stay as focused as you can. There's two types of ellipses. The first one I'm going to talk about is a horizontal ellipse. Horizontal is going to be wider than it is taller, so it's going to look like this. Okay, that's going to be a horizontal ellipse. The way to identify if you have a horizontal ellipse is in the equation. Notice that we have x squared over a squared plus y squared over b squared equals 1. This will always be plus, this will always be 1, but this a squared could move back and forth between being under the x squared and the y squared, okay? The thing to remember is that a squared is always the biggest number, okay? So make a note of that. A squared is always the biggest. A squared is biggest, okay? And if we have a horizontal ellipse, then a squared is always going to be under the x squared term. That's how you look at an equation and tell whether it's horizontal or vertical. If a squared is under the x squared, then it's horizontal. If a squared is under the x squared, then it's horizontal. For the ellipses that we're going to talk about, we're going to center on 0. So 0, 0, okay? So every ellipse has a major axis. For a horizontal, when a squared is under x squared, the major axis is horizontal. It means it goes from left to right. So the axis here, I'm going to draw it out better on the next slide. The horizontal one, that's the major one because it's longer, okay? The vertices are always at the ends of the major axes. The vertices are always at the ends of the major axes. So notice something. Do you see how a squared is under x squared? All right, so that means that when we write the vertices with an ellipse centered at 0, 0, a, the square root of a squared, a has to go in the x spot. Negative a has to go in the x spot, and positive a has to go in the x spot. It's because a squared is under x squared. A squared is the biggest of the two denominators, okay? I'm going to skip to the foci real quick here. The foci is also under the on the major axis, okay? And notice how it is also in the x spot, okay? The way to calculate the foci, c squared always follows this relationship a squared minus b squared, okay? I'm going to give you a little bit more info on that tomorrow in class, but I didn't want to take video time for that, okay? Now the co-vertices, these are always on the minor axis. I don't have the minor one listed, but it's the shorter of the two. Minor, shorter, major, longer, okay? And notice where b is. B is placed under the y squared. B squared is under y squared, okay? So what that means is that my co-vertices are going to be in the y spot, okay? All right, now let's talk about a vertical ellipse. It's going to be taller than longer, okay? And look at how the biggest denominator, remember a squared is always the bigger of the denominators. A squared is now under y squared. That's a really important feature. So if the bigger denominator is under the y squared, you're going to have a vertical ellipse. The major axis is vertical. It's the longer. Makes sense because it's longer than it is wide. Okay. The vertices are going to fall on the major axis. So notice that a squared is under y squared. Look where your a's are now located. They're in the y position of the ordered pair. They're in the y, so you have negative a and you have positive a. Okay? Again, we're going to focus on centering on 0, 0. Okay? Look at the foci. The foci, c, which is found the same way, c squared equals a squared minus b squared, they're also in the y position. So if you have the foci in the y-coordinate spot or the vertices in the y-coordinate spot, then you know that you have a vertical ellipse, okay? The co-vertices now are in the x-coordinate of the ordered pair, all right? Because it's not as wide, it's the shorter distance, okay? So let's kind of put this on in a picture, okay? So we're going to start with horizontal, and with a horizontal, we have x squared over a squared plus y squared over b squared is equal to 1. So remember that it's important that we know that a squared, the biggest of the denominators, is under x squared, okay? So the first thing that we have is we have the major axes. It's horizontal because a squared is under x squared, okay? On the ends of the major axes are the vertices. So you take the square root of a, and it's going to be the negative of the square root of a, comma 0, and the positive of the square root of a, comma 0. Okay? Notice that these are in the x spot in our ordered pair. Notice that a squared is under x squared. That will always correspond. Those are some key features that you want to look for. The next thing that I'm going to talk about is the co-vertices and the minor axis. This is the shorter of the two. Shorter. A major is longer. Okay. Its length is 2b, while the major axis length is 2a. Okay. And notice that b squared is under the y value, the y squared. Look at where b squared is. It's under y squared, right? And look where b is located in the ordered pair, in the y position, okay? The last set of points that we're going to look at, these are the foci. The foci correspond with the same axes as the vertices. And notice that they're in the x spot, okay? They're in the x spot. So if a squared is under x squared, then the plus or minus a's are in the x spot, and the plus or minus c's are in the x spot. Now let's look at a vertical. And this one, we talked about this earlier, but a squared is now under y. Always equal to 1. So we have x squared over b squared equals y squared over a squared, which means now my major axis is the vertical one. And notice here that my a squared is under the y squared, right? And notice that my a is now placed in the y-coordinate position. That will always happen, okay? The length of our major axis is 2a, just like it was over here. Now we have a minor axis, which is the smaller of the two, and its length is 2b, and notice where b squared is positioned. B squared is positioned under the x squared, right? And notice where my negative b is and my positive b is. It is in the x spot. That's not a coincidence, okay? And then the final thing, the final set of points on this one, whoops, went the wrong way, is the foci. And again, the foci are on the same axes as the vertices. Sorry. Okay, C and negative C. And remember that, I'm going to put these as green too, okay? And remember that we talked about that C squared is equal to A squared plus B squared. So we use minus B squared. Sorry, I go into Pythagorean theorem mode there, minus B squared. Okay, and let me get that. And this C squared corresponds to these C's. So these C's right here are the square root of this number, right? All right, that's a lot of information. So now let's use some of it. The first thing that we're going to try and do is we're going to write an equation of ellipse in standard form. Our center is going to be at 0, 0, and we're going to be given the vertex and given the co-vertex. And in your daily assignment, it's not going to have a V or a CV, but when you see this phrasing called listed respectively, that means that whatever is first is the vertex and whatever is second is the co-vertex. So the first thing that we have to do is we have to identify A and B, all right? So I'm going to refer you back to slide 2, okay? Just keep looking at slide 2 until you get used to some of this, okay? This is my vertex. So my A is going to lie, my A is always going to be part of my vertex. So this must be an A, all right? So since this is the A and it's in the X spot, see how A is underneath the X? That means that A squared has to be under X squared, okay? Here's my co-vertex, so let's look at that. This has to be my B, and it's under the Y. So that means X squared over Y squared. X squared over A squared plus Y squared over B squared has to equal 1. Okay? Now, so we've determined that A squared has to go under X squared because my A is in the X spot. Okay? Now, we've written the equation, and now we're going to plug in. So we have X squared over what's 4 squared. And then we have Y squared over what's B squared. So I have X squared over 16 plus Y squared over 4 equals 1. Okay, so now I want you to try the video question, all right, and see if you can come up with the equation of the ellipse. I hope that went well for you. Let's do another one. Write an equation of an ellipse in standard form with center at the origin, so that means I don't have an x plus or minus a number. It's just going to be x squared and y squared in my numerators, with the given vertex, here's my vertex, and the given co-vertex. Okay, so I have to identify A and B. A is always associated with the vertex, so this has to be A. It's in the Y spot. Okay? So, since A is in the Y spot, then A squared has to go under Y squared. Okay? And this is B, and it's in the X spot. So that means B squared has to go under X squared. Well, that looks crumbly. Now I'm going to write my equation. It's x squared over b squared plus y squared over a squared equals 1. So now I'm going to plug in. So I have x squared, b is -2, -2 squared is 4, y squared over -3 squared. And so I hope I can fit this in. I get x squared over 4 plus y squared over 9 equals 1. Why don't you try the video question? Okay. Now we're going to learn how to look at an equation and figure out what the foci is. Okay, so we're looking first for c squared. Okay, so we have to find c, but first we're going to find c squared. So which is a squared and which is b squared? A squared is the largest. Okay, so this means that a squared has to equal 25 and b squared has to equal 16. So now I'm going to use those two numbers to find c squared, which is going to give me c. Okay. So c squared is going to be 25 minus 16, so that's 9. So c is going to give me plus or minus 3. And now we need to write vertices and co-vertices and foci so that we can graph it. So my vertices are going to be, because a squared is under x squared, that means a has to go in the x spot. So this has to be -a, 0, and a, 0. A has to be the square root of 25. So we're going to have vertices of -5, 0, and 5, 0. My co-vertices are going to come from my b squared. They're going to have to go in the y spot. So I'm just going to abbreviate this as 0 plus or minus the square root of 16 is 4. 0 plus or minus 4. This shorthand would be plus or minus 5, 0. Sorry, my voice is getting crumbling. All right, now my foci, they have to lie on the same axes as my vertex. So that means that my foci also have to go in the x spot. So I get -3, 0 and 3, 0. And in shorthand, that's going to be plus or minus 3, 0. So now all I have to do is plot these points. So here's 5, 0. Here's -5, 0. Here's 0, 4. That's a co-vertex. Here's 0, 4. That's a 0, -4. That's a co-vertex. And then my foci is going to be -3, 0. and positive 3, 0. These two are always on the inside. The foci are always on the inside of my ellipse. So now I just connect it like that, and I know it's crumbly, but that's the best I can do on this kind of device. Okay. Now let's try another one where we're not quite in that ellipse equation form. So what we have to do first is I have to get this to be a 1. So I have to divide every single term by 144. So I get x squared over 9. I divided top and bottom by 16. Check that out if you need to. And then I have y squared over 16. I divided top and bottom by 9 is equal to 1. Okay. Now I have to identify a squared and b squared. A squared has to be the biggest. So what's the biggest? Well, 16. So this is a squared. So I'm going to have a vertical ellipse, which means 9 is b squared. Okay. I use the same formula, c squared equals a squared minus b squared, and I'm going to find c squared. So I get c squared is equal to 16 minus 9, so that equals 7. All right, so now I have to find a and b and c by taking the square roots of these numbers, okay? So a is equal to plus or minus 4, b is equal to plus or minus 3, and c is going to be plus or minus the square root of 7. We'll just leave it like that. That's fine. Okay, so now my vertices, my a squared is under y squared, so a has to go in the y spot. So I'm going to have 0, negative 4, and 0, positive 4. My co-vertices, b is under x, so that means my b values have to go in the x spot. So I have negative 3, 0, and 3, 0. And my foci have to go in the same spot as my vertex. So it's going to be 0, negative root 7, and 0, positive root 7. Okay? All right, so I'm going to graph these. So here's my vertex, 0, 4. Here's my other vertex, 0, negative 4. My co-vertex is negative 3, 0. My other co-vertex is 3, 0. And my foci, okay, so if this was the square root of 9, we would be at 3. So this is kind of like halfway between the square root of 4 and the square root of 9. So I'm going to say it's about like 2.5-ish. Okay? So these are my foci. 0, root 7, and 0, negative root 7. Okay? And we did it. Now all we have to do is draw our ellipse. So this has got to be taller than it is wide. It's going to be like that. The closer your two denominators are to each other, the more round and the more circular we're going to get. All right, so now we're going to find the focal length, and we're going to find this based on the length of the major axis and the length of the minor axis. So the major axis has to be the longer of the two. So you take the bigger number, all right, and we're going to find A from that. So this is the longer or the bigger of the two numbers. So 2A has to equal 6. How do I know that? Because the length of the major axis is the longer one. So 2A has to equal the bigger of these two numbers. Okay, so that means A has to equal 3. The length of the minor axis, 2B, has to equal 4. And so B has to equal 2. And so now we're going to use C squared equals A squared minus B squared. So I have C squared is equal to 9 minus 4, which is equal to 5. So C is equal to the square root of 5, and 2C is equal to the square root of, is equal to 2 times the square root of 5. Okay, so the square root of 5 is just over 2, so this is going to be roughly like, maybe like 4.3-ish, 4.2, 4.3-ish. Okay. So why don't you try the video question? Okay. I hope that went well. If you're not sure what happened, write it down and let's talk about it tomorrow. So we're going to write an equation for the ellipse given the foci and the co-vertices. So the foci will help us determine the direction, whether it's horizontal or vertical. Okay, co-vertices is going to help us back into A, our vertex. Okay, so look here, our focus is plus or minus 4. This is an X, this is a C, right? Our co-vertice, this is a B and this is a Y. Okay, so this means that our A squared has to go under our X squared because C and A are on the same axes, the major axes. So if C is an X coordinate, A squared goes under the X squareds, and if C is a Y coordinate, A squared goes under the Y squareds. Okay? So let's use C squared equals A squared minus B squared to find A squared. So I have 16, that's C squared, is equal to A squared minus 1 squared, which is 1. So 17 is equal to A squared. Now I'm going to plug it into this equation, and I get X squared over 17 equals, oops, doesn't equal, plus Y squared over B squared is 1 equals 1. All right, and we did it. All right, why don't you try the video question? Let's try another one. Write an equation given the foci and the co-vertices. All right, so look where your foci is. This is a C, and it's in the Y spot. So that means that my A squared has to go under my Y squared. Okay, so let's use C squared equals A squared minus B squared. So I have 1 squared, which is 1, has to equal A squared minus 2 squared is 4. Whoops. I'm not going to change that. I'm done fighting it. I'm going to add 4 to both sides, so I get 5 is equal to A squared. So now I know that a squared has to go under the y squared because my c is in the y spot. Okay? So you have to think through that. So now I have x squared over 4 plus y squared over 5 equals 1. So why don't you try the video question? All right, we're going to spend 2 days on this. And so actually we're going to do, I think I'm going to move this down to day 2. And then 15 through 17. So we're going to stop around the 12 to 14 problem area in class tomorrow. Okay. Thank you so much for listening and watching with me and letting me teach you through video. I appreciate it.